Hello, we are Team 14615 Turbocharged.
We are a community team, and today we will be demonstrating how we did our prototype and design processes. After the game release, we wrote down the different ways you can score. After that, we figured out what the best ways to get points are, and then focused on those points when building prototypes in our smaller groups. Such as last season, we did it, and we thought the skystone, block placement, capping, and foundation removal had the most points beneficial to us. So we got into our smaller groups and started prototyping right away.
Hello, I'm Ryan, and today I will be talking about prototype chassis. Making two wooden prototype drivetrains will allow multiple groups to work without having to deny access to the robot from a build group. This is a sheet of hobby plywood that we use to make the chassis. It is only $5. This is one of our modular drivetrains. We use this AndyMark gearbox cap as a template to be able to drill out the holes and allow us to put motors anywhere on this. We use it to be able to experiment with our wheel placement. This is one of our prototype mechanisms. Using these chassis, we can easily go and screw on one of these prototypes. And at any moment we can take it off, fix it, and do whatever we need with it. This is one of our programming robots. We set it up to be able to allow our programmer to test autonomous. I'm now going to show you the basics of making a wooden chassis. First, you're going to want to design and measure the drivetrain you want. Then cut out the wood into the wanted design. When assembling the chassis, you're going to want to use wood glue along with the wood screws. We also like to go and keep a nice flat surface for our electronics. When applying the wood glue, you want to keep nice little beads along the surface of the wood. After you apply the wooden panel, you're going to want to insert the screws to make sure that it is in the correct position. And there you go. You have a temporary wooden chassis to use for prototyping.
For prototyping, we used some basic materials around our shop, such as cardboard, tape, popsicle sticks, surgical tubing, and rubber bands, and silicone material that we bought. And when we got to more advanced prototypes, we went to wood, 3D printed plastics, and various materials on this board. When you get further into your prototyping design, you can go with plywood, 3D printed plastics, surgical tubing, zip ties, and carbon fiber hockey sticks.
That's better. Hello, I'm David Gray. I'm an alumni from Team 14615 Turbocharged, and today I'll be explaining our design process and what we do throughout the season. We started our season by holding a kickoff at North Central College. Shortly after kickoff, we began working with the aforementioned wooden chassis. With the chassis assembled, we began working on intake mechanisms. As the intake team was proving their design to be a success, the lift arm team was well on their way to a working prototype. We continued to test the prototypes throughout development, and were always sure the robot fit the constraints. We combined all the working parts on one chassis, but developed multiple chassis so that we could have side-by-side development with the programming and build teams. Not all prototypes worked. Some had to be swapped out for better alternatives. As the designs came together, we continued to develop our final chassis. We continued improving and developing our designs to get them to work in their most optimal condition. It's important to keep working towards improving your robot even after the first competition, because the challenge is only going to get steeper from there. Having left plenty of time to test the robot, we trained up our drivers to ensure that they were ready for competition. Throughout the season, we continued to develop new designs and improvements, such as a tape measure mechanism to park. With all the designs working well and the robot laid out, we began to work on the final chassis. We build our chassis out of G10, a composite material which is very strong and cost effective, which also negates our issues we've had with static in previous seasons. With the individual parts connected to the final chassis, we conclude this brief tour of our previous season. Here are three of our designs from throughout last season. For example, our capstone, which we had designed so that the arm can grab both the block and the capstone at the same time. We found this both saved space and time on the robot and throughout the game. Speaking of the lift arm, here are two of the designs we used on the form of the lift arm earlier in the season, one of which was a scissor lift, which, despite its functionality, it was rather slow and took up a lot of space, which is why we moved on to using this, which is a linear slide arm. We found it to be much more compact, faster, and capable of reaching a much higher height. It was much more effective overall, which is why we ended up using it as our final design, because that's what the design process is about, figuring out what's going to work the best, and developing it until it's working at its most optimal condition. During the design process, there's some things you need to remember. For example, you need to make sure there's enough time to test the robot before competition. It's okay to make changes and add additions to the robot to make sure it performs better, but make sure you got enough time to test it so that you can ensure it will work when it comes time for the season to start. Also, make sure you're working with your programmer. Building's only half the battle. If the program's not there, the robot's not going to work. So make sure you have enough time for them to work on the program, as well as giving them time during the development of the robot to figure out new parts.
Thank you for joining us today and listening to our presentation. We'd like to wish you luck in the upcoming season Ultimate Challenge. Will you rise up to meet the ultimate goal? Bye.
Bye. See ya.